Welcome everybody to this fifth lecture on Python. In this lecture, we'll cover scientific computing with the Numpy library. In particular, we will cover the Numpy arrays, which is the main topic of the Numpy library. As I said before, in this lecture, we will cover the Numpy arrays and all its basic structures. Also, we will learn some function of NumPy used for create arrays. We will know that NumPy arrays can also be multi-dimensionals. Finally, we'll cover a few NumPy functions that I believe you should know already. And as every other lecture, we will sum up everything at the end. Again, I would like to let you know that this lecture series is available on the group page by Math on GitLab. You can see the links below. Numpy arrays. What are numpy arrays? Numpy arrays are just the visual equivalent of vectors in linear algebra, which means you can also do mathematical operation with it and everything that you do in linear algebra. To import NumPy arrays, we first need to import the NumPy libraries, as we have learned in the previous lectures. To import our libraries, we need to use the import functions, name of the library, and then if we want, we can also rename the name to call it. In this case, you usually use np for NumPy. In this, we use this format. To create an NumPy array, we use the array function of NumPy, and this is a basic structure, and you create an NumPy array using the square bracket inside the function array. You can also use a list. As other arrays in the basic structure of Python, as list and tuples, NumPy arrays can be, you can do indexes, which means you can add elements through square brackets. This is the basic structure. So we are in the Python shells. We have an array called A, and we write inside the square bracket we have n, and in the index of the element we want to access. Like standard Python arrays, indexes start at 0. Remember it. Index array. To understand better the concept, look at the following examples. In this case, for the entire lecture, I will going to use IPython shells. So I have before I import Python and NumPy, I create a NumPy arrays as follows. Then I say, okay, let's create a function through for loop. So for in the range, so a range start at len a, so the length of the array in this case is 5. So we'll start by the first element would be 0, and last element would be 4. And then we are taking, okay, n equal to a high, so index I. Then we want to print it, this element, and also write as a tuple our e component and our n, the value of a. Then we run it. As we see, a0 is 1, a1 at position 1 is 2, and so on until a position 4, that is 5. Okay, index array. Python, as for the other arrays at the start, can use negative indexes. So an index with index -1 or -2 and so on is basically the last element, -1, -2, second to the last element, and go ahead. As in the example, 8 - 1 is the last element, which was 5, minus 4 is the first element because our race was long 4 and it gave us the right. Okay, slicing as list and tables. We can also slice numpy arrays. And a way to do it is the following. We have our numpy arrays A, then we use the double dots to split the starting end point of our elements. So, and it will going to give us the numpy arrays from position n to position n minus 1. Look at the example. Let's create an numpy range with a range function. So the range function start from 0 in this case until 9 because we're in 10 until 10 minus 1. We want to print A, and the slice option, and indeed we have from 0 to 5, and the first one is the entire, and the second from 0 to position 5, and indeed it works. Like standard arrays, you can leave off either n or m. So look at the examples. We want to print 8 from position 0 to position 5 because we do not put everything index number. It means that we start at the beginning. We want to enter 5. Also other way around, if we leave out the m, then it means we want until the end. Okay. Like standard arrays in Python, we can also decide the step size that the slicing can do, and we can do that by just add an additional double dots. Look at the examples. The function, the array is still the array created from the range function until 10. This time we want slicing the arrays between 0 and 10, so the entire arrays, but with step size 2, so indeed 0, then at position 2 we were 2, and so on, as we can see in the example. Negative step size work as well, if you are wondering. Mathematical operations. As I said at the start, the nice thing about numpy arrays is just that the digital equivalence of vectors in mathematics, which means you can do mathematical operation on it. Look at the example. Let's create a basic numpy range from 1 to 5. Then we want to have the multiplication by 2, and it work. We want to have a sum, two different two arrays. Yes, in this case I use again 8 for simplicity, but it works as well. We want to subtract two elements. Naturally work again. We want to divide every element components by 2. Again, it works. We can also compute the power of each element in it, and yeah, it works as well. Mathematical operation on arrays. But what about multiplication between its arrays? As you probably know from mathematics, the multiplication between two vectors can be seen in the Euclidean space as a dot product, or we can also do an outer product for two vectors. Okay, and if the question you may have, what happen when we multiply a times a? Does it happen, or more generally a times b will give an inner or outer product? The answer is neither. By writing a times a's, you just do element of rise product. which means you are multiply each element for the two vectors by itself, as we can see in the slides. It can be quite straightforward, the reasoning, because as we see in the previous slide, when we have the power, compute the power of each element and not the power of the entire arrays. But if I want to do a dot product on outer product or any other product that you want to do with a vector, well, you don't worry. You can either create a function yourself or you can use the inbuilt functions of Numpy, which has dot, an outer product, and any other product. So take for example, np dot AA. So we are doing the dot product with AA. You give our results. You can check by hand that is indeed true. And outer product the same again. You can check by hand, but I will not do it. So yeah, sometimes you need to create big arrays, and it is not convenient to write a list by hand yourself as we did before. So Numpy came in our helps, and we can use some inbuilt functions like np0s to create a numpy array with, in this case, as the size 10, so 10 element with valued at 0, or with ones, so a numpy arrays with 10 ones. Yeah. Okay, another important function the NumPy give us is the linspace function, which returns an array with linear increasing values. To understand it better, look at the example now. We are creating an NumPy array with this function, and we want the values inside our arrays to be from 0 to 10, but we want arrays to have length 5. So look at this example. We run it. We have the 0 because we started 0. Then then 2.5. So we have a size of 2.5 and until 10. It's kind of nice. Another nicely function that you're going to use to plot other functions or for any other reason is the random functions. We return random numbers. It works in this way: np random 10. So we print a. We want to have 10 random numbers, and there you go. You're going to mainly use this function when, for example, you need to check a function that you have designed works well. Maybe you are computing a linear system and you want to check if your implementation worked nicely. And so you want to have a matrix with random numbers in it. How does this function works? Well, it generates the number in an uniform way from 0 to 1. There are also other ways to generate random numbers, and you can check the docs on numpy.org. Okay, obviously vectors can also be n-dimensional, so matrices and numpy arrays allow you to work with those as well. To create a numpy arrays n-dimensionals, you can use this same function we have learned before, but instead to have just one number, you're going to have 2 entries, or if you have 3-dimensional, 3 entries, and so on. So, for example, we want to create a matrix, 2-dimensional matrix with 3 columns and 3 rows, and we just write np0 square bracket 3 comma 3, and yeah, there you go. We can use also the one function instead to have completely 1, so that's really nice. Okay, I think that we need to keep in mind is when we check the len, it gives you not the entire 3 times 3, but just one of the dimensions, not both dimensions. To have both dimensions, you should use the shame functions. So, for example, print c keep 3 because you have 3 dimension for on the columns and 3 rows. Okay. You can also slice and index array, multi-dimensional arrays, as we did for one-dimensional arrays. So, for example, in this case, we are using the matrix that we created before or completely 0, and we say, okay, consider the matrix, the index from 0, so the first lines, and then all the columns, and you want to change with 1 through 3, and then we want to change the second lines and all the columns with 4, 5, 6, and the last line and all the columns with 7, 8, 9. We print and there we go. And any other slicing operation that we use for vector can be used for multidimensional arrays as well. The only thing to keep in mind that you need to put the commas, otherwise you just considering the columns, the rows, sorry. Okay. As before, we can start rows and columns in broken matrix. So for example, we start with the first line, not the second line, sorry. We are considering all the lines but the first column, so we are printing the second column, sorry. And in here we are considering, okay, take the second line because recall that we started 0 for indexing, and use all the lines afterwards that. Then for the columns, take the second columns or the one afterwards that, and we have this matrix. Okay, to have additional functions and properties for multi-dimensional arrays, go to numpy.org or shipeyes.org. Shipeyes is the optimized versions, a better optimized version of NumPy. Okay, we can also use to make functions MPI, which a nice way is basically we are creating identity matrix, in this case of size 3. We can also make an identity matrix that have the ones move to another diagonals. And yes, for use k-1, we are using the diagonal below the center. If you k equal to +1 is the one above, +2 is the one above that one as well, and so on. A nice property, so just nice function, just have a look at it. Okay, NumPy function, as I said before, NumPy has a lot of inbuilt functions which are highly optimized, and there are like average, standard deviation. You can do all kind of statistical analysis with NumPy as well, square roots, minimum, maximum, argument minimum, so on. Just have a look at it on the reference shimpys.org or numpy.org. Here's some links that you can go check out it. To sum it up, the NumPy arrays are basically the digital equivalents of vector and linear algebra. You can do indexing as slices operation in the same way you do for list and tables. They can also be n-dimensional arrays. like matrices. You can do mathematical operation in the same way you do in on papers, although you need to be careful about the multiplications because you need to use the inbuilt function of like dot products or other products, because if you just use the asterisk you're going to have index wise product and not the outer product or inner product. With Numpy you have a huge library or inbuilt function that are highly optimized for any needs you may have in mathematics. So yeah, have a look at it, in particular linear algebra. Thank you for watching these 5th videos. I hope to see you the next last videos, which is going to be on plotting data using Python. Yeah, thank you.